It's chemistry and you are watching Chem Science.
In our earlier video, we have already discussed question 1 and 2 of question paper 51 or 53 of the examination series May-June 2023 9701 chemistry. Now in this question, we'll discuss the remaining question 3 fully and also will discuss few important tips to solve question paper 5. So without wasting any time, let's start discussing question 3, where it says a scientist is asked to find the rate of decomposition of an aromatic diazonium compound and determine the order of the reaction with respect to the aromatic diazonium compound. Now the sub question A says the scientist is given 1.02 gram of an aromatic diazonium compound in a 50 centimeter cube beaker. Now we just need to understand that it's just a 50 centimeter cube beaker. The capacity of the beaker is this, and in that we are given 1.02 gram of aromatic diazonium compound. Now the main question says that describe the steps the scientist should take to make 100 centimeter cube standard solution containing 1.02 gram of this compound. Give the name and the capacity of the apparatus the scientist should use. Now we are supposed to describe a series of numbered steps. Now we are going to discuss the numbered steps. Now numbered steps doesn't mean we have to describe it in steps 1, step 2. You can just write a bullet points, or you can just write in a paragraph also, but then it should be describing stepwise, in the sense what step or the what method should be followed first, following it what should be done. So the procedure has to be described in a stepwise sequence method, so that one after the other method can be understood well. So if we start with that, 1.02 gram of this compound should be dissolved first with the help of distilled water, and it is given in 50 centimeter cube of beaker. So our first step should start with add little amount of water, add little amount of, now I'm specifying here, little amount of distilled water. That is very important, because whenever we make a solution we use a distilled water. So here we should specify that we are adding a distilled water to the salt in 50 centimeter cube beaker to dissolve it and dissolve it. So this is the first step. Now after dissolving, what we can do is, now again if we have a look at the step here, we are going to make 100 centimeter cube standard solution containing 1.02 gram of this compound. So we are supposed to make 100 centimeter cube solution. So what apparatus should we use to make an 100 centimeter cube? And that is volumetric flask. To make any solutions we use volumetric flask, and the capacity of volumetric flask is varying. It can be 100, it can be 250 centimeter cube, it can be 500, it can be 1 dm cube also. So here we are using 100 centimeter cube volumetric flask. So what are we supposed to do is transfer this solution, the one which we have made in the first step, transfer this solution in 100 centimeter cube. Now we are specifying it 100 centimeter cube of volumetric flask. We are specifying the capacity and the name of the apparatus, that is volumetric flask. Here I am also adding along with 2-3 washings. Means what? That after the solution, the dissolved solution we are transferring to 100 centimeter cube volumetric flask, we will wash the beaker 2 to 3 times with distilled water, with a very small amount of water, and that washings also we will transfer into the volumetric flask. So when we say along with 2-3 washings, means after transferring we are washing the beaker 2-3 times with very small amount of water, and that we are transferring. So here is the second step. After making up the solution, now what we are going to do is this is a little lesser than 50 centimeter cube because we had taken the beaker of 50 centimeter cube. So what we are doing is, now we will make the solution, make up the solution. We can write that also. Make up the solution up to the mark. Now each of the volumetric flask will have a small mark on the neck of the volumetric flask. So make up the solution up to the mark with distilled water, so we'll be adding distilled water to the volumetric flask up to the mark. So make up the solution up to the mark with distilled water and shake well. So this is how we are going to make the solution of 100 centimeter cube with 1.02 gram of the compound. So here you can see that we have written 3 important steps where we had included some smaller minute steps also into it, but then there are 3 important steps, and for that you can see that there are 3 marks here. So this question carries 3 marks, and so 3 important steps which we have described here is required. So let's go ahead with the next sub question, where it says that benzene diazonium chloride, an aromatic diazonium compound, decomposes in solution to produce phenol and nitrogen gas. So now what is happening? A reaction is happening where this compound is decomposed into phenol and nitrogen gas. The scientist warms 50 centimeter cube of the solution to 50 degrees Celsius. The scientist records the volume of nitrogen gas produced at different times during the decomposition. So here a reaction is going on where a gas is produced, that is nitrogen gas, and we are going to measure the volume of nitrogen gas at a a specific 50 degrees Celsius. So the temperature is fixed here. So let's read the sub question. It says, identify the piece of apparatus that should be used to maintain the temperature of the solution. Now if you want to maintain the temperature of solution in any experiment, the only apparatus which we use is thermostatically maintained water bath. Thermostatically maintained water bath. Water bath is something which is used to maintain the temperature, and this is thermostatically maintained, means we can fix the temperature of the water bath and we can perform the reaction in this water bath. Now identify the dependent variable. Now dependent variable is what? The factor which we are measuring. Now in this experiment you can reread the question here. What are we measuring? We are measuring the volume of nitrogen gas. So dependent variable is the volume of nitrogen gas. For any experiment, whenever it is asked what is dependent variable, so whatever you are measuring in this experiment, that is going to be the dependent variable. Now let's also discuss what is an independent variable. Independent variable is the one which you change during the experiment. Now suppose if we are changing the temperature in this experiment, suppose if we are changing the temperature, then the dependent variable will be the temperature. Now what are we measuring? We are measuring the volume, so that is dependent variable. And what are the controlled variables? Controlled variables are the one which we keep same, the factors which we keep same. For example, if we are performing the experiment with various number of solution, then the volume of solution, concentration of solution, that can be controlled variable. So the factors which we keep same throughout the experiment is called controlled variable. Now here we are asked only about the dependent variable, so we are writing whatever we are measuring, that is volume of nitrogen gas. Let's go ahead with the third sub question. Says, suggest why the scientist does not monitor the reaction by measuring the loss in the mass. Now main thing is if we are measuring the mass during the experiment, we need a weighing balance. Now the problem is that we are performing the reaction in the water bath. So when the experiment is or the apparatus is in water bath, it's not possible to weigh it on the measuring or the weighing machine. So we can just write it is not possible to weigh the apparatus, or you can even write weigh the mixture. Weigh the apparatus during the experiment when it is in water bath. So this is why we cannot measure the mass. So we can measure the loss or the change in the volume of gas, specifically nitrogen gas. So here is question B done. Let's go ahead with question C. So sub question C shows that table 3.1 shows the results of the experiment, and here is a table with three columns where first column shows time in minutes, volume Vt in centimeter cube, and the third column says V final minus Vt. Now V final is given here 57.2 centimeter cube, means what is the final volume of gas produced during the experiment, that is V final, and V final minus Vt that we have to fill up in the third column. So what we have to do is keep on subtracting, that is 57.2 minus 0.0, so we need to write 57.2. So here we will keep on writing, and you can just pause the video. Wait, I'll complete the table. So here I have filled up the third column. Now you can see that I have written all the answers in one decimal place or three significant figures. The reason is that in the column here Vt, we can see that the answer is written in one decimal place. So the third column where the subtraction of the volume is done, there also I have written with the same number of dp's, that is decimal places, that is one decimal place answer we have written. Here at the bottom of the table, it's also written and shown that V final is the final volume of nitrogen gas measured once the decomposition is complete. So the whole reaction is allowed to complete, and then the final volume is measured, which is calculated as V final, and Vt is the volume collected at time is equal to T. Now V final minus Vt is given here that it is proportional to the concentration of benzene diazonium chloride. What is proportional? V final minus Vt means the third column which we have written here, that is proportional to the concentration of benzene diazonium chloride. So if greater is the value, the benzene diazonium chloride is having a greater concentration. So if the values here is decreasing, that shows that the concentration of benzene diazonium chloride, that is the reactant, the concentration of reactant is decreasing as the time goes by. So the sub question A says complete the table 3.1, which we have already done, and the next sub question says plot a graph on the grid in figure 3.1 to show the relationship between V final minus Vt and time. Use a cross to plot each data point. Draw a curved line of best fit through the plotted points. So now we are going to draw the table again. I am going to pause the video and I'll finish the graph plotting while you can take some rest. So here I have plotted the points. You can see that in the blue I have plotted the blue crosses, you can see, and then red line as in smooth curve. I know my curve is not very smooth because I'm drawing it with a pen, but when you draw it with a pencil, it's going to be a smooth. To get 2 marks, it has to be smooth. So for me, you can excuse me because it's a pen. Now let's see that what were the sub questions on the top, where after plotting they said in the third sub question, say circle one point on the graph that you would consider to be most anomalous. Suggest one reason to explain the anomalous point you have circled. Assume no error was made in the measurement of the volume. Now if we talk about circling, we have one point here which is according to me out of the curve. Okay, Now the thing is that it has to be on the above. The volume should have been higher, but if the volume has decreased, that shows that the time has passed by. If the time has passed by, that shows that the volume was measured later than the actual time. So we have circled. We can say that the error is because the volume of gas was measured late or later, was measured later than the actual time, So because if it had been measured on the time, then the difference should have been greater. So now it's lower, so here is one reason. Now use your graph to find out the first two successive half-lives, t half, for this reaction. State the coordinates of both the points you have used in each of your calculation. So we are supposed to calculate the two consecutive half-lives from the graph. Now if we talk about the graph, the final volume is 57.7, and so the half of it should be the first final volume was 57.2. So if we calculate the half of 57.2, it is 28.6, and 28.6 is somewhere here. I'll say it here. I've made a cross here. And so if we find out the time for it, the time here, if we find out, it's going to be 11 minutes. So the two coordinates here, what we write here, the first coordinate here is 0 minutes, that is on y-axis. It should be 28.6, so 28.6, and the x coordinate is 0, so 0 comma 28.6, and you can see that the time here is 11. So x-axis here is 11 minutes, and for that the volume change is 0. So these are the two coordinates, and so the half-life is 11 minutes. Now if we go for the next t half, let's go ahead. So if we have the first t half volume is 28.6, then the second t half volume, that should be again divided by 2, that is 28.6 should be made half, and so the answer is 14.3. So our second volume change for the second t half should be 14.3. So if we say 14.3, so 11, 12, 13, 14, so 14.3 somewhere here. I'm making a cross here. So this is the second t half volume, and so if we extend it, and extend it up to the curve, and then find out the time. So if we go to the x-axis here, you can see that it is approximately 21 or 22. I'll say that it is, if we find out this exactly, it is 22. So let's go ahead and write the second coordinate values for the second t half value. So here we know that on x-axis the value is 0, and the y-axis value is 14.6. we know that. And as we had find out the time here, it was 22. So x-axis value is 22 and the y-axis value is 0 for this point. So these are the two coordinates which we have used to find out the half-life. And so the second half-life is again the subtraction of these two, that is first half-life minus the second half-life. So the second half-life is again 11, because when we calculate second half-life, let me specify here, the first half-life is this and the second half-life is this. Means if we say this is T1 and this is T2, then the second half is T2 minus T1. The difference between the timings of the first half-life and the timings of the second half-life, that will give us the second t half. So this difference is also 11. So first half-life is 11 minutes, second half-life is also 11 minutes. So from that we can conclude is a first order. But let's read the question 6. It says, use your answer to C5 to state the order of the reaction with respect to the benzene diazonium chloride and explain your answer. So obviously the reaction is a first order. Reaction is first order. Why? Because both the half-lives are constant. So we can say that both the consecutive half-life, consecutive means one after the other. So both the consecutive half-life are constant, and so it is first order. So whenever the half-life is constant, it is first order. Suppose if the half-life is increasing, then it's a second order, and if the half-life decreases, it's the zero order. So here we had the constant half-life, so it was the first order. Now here ends the third question also. We had discussed first and second question in our earlier video, and so we have finished discussion the question paper 5.1 and 5.3 here. 5 and 5.3 both were same, so we had taken it together as same.